Okay, chi-square goodness fit test. Okay, so 10-1. Okay, back in chapter 4, we did binomial questions, yes, no, etc. But what if there's more than two choices for a question? Okay, what do you do then? Okay, now they call this multinomial. More than one really is what it means. Okay, so to look at this, we'll use example 2. Okay, in 10-1 on page 543. And what you'll need is your book, calculator, and gold key formula packet. Particularly, we're going to be looking at table 6. So your book, and there's some of table 6 there. We'll be looking at that table 6 for chi-square distribution. Okay, here's example 2, and here's what we're talking about by more than two choices. So it's a survey to see how people prepare their taxes. Okay, here's the 5 choices. Okay, now this is old. This is from the past. Okay, so what someone wants to know is has it changed? So, for instance, are more people using computer software now? So they do a survey. They ask 300 people. Here's the results they get. So obviously there's an issue here, right? If we're going to compare, here's the new, there's the old, that's percent, and that's numbers. Okay, we'll deal with that in a second, but let's look at, how do you get your calculator set up to use the chi-square goodness fit test on your calculator? And the start of that would be this. Okay, you go to Stat Edit, List 1, List 2, make sure they're in this order. Observed will be your List 1, Expected will be your List 2, but here's Expected. Expected was percents. We need numbers. What do? We take 300 times these percents, okay, because that's what's expected out of the 300. Okay, so we get those numbers, we put those in as list 2, and now we're going to see, is there a difference? Now the way they set these up with the hypothesis statement is the null is always that the things are the same as they were before. So you'll see that they say the tax preparation methods is 25%, is 20%. Okay, and that's coming from right up here. So it is this. So the null is this is what it is, and the alternative is that it differs. Now in this case, they want to know, they claim there's a difference. Okay, so you notice that they've labeled the alternative as the claim. Okay, but so we got to test this, right? First, let's go to a picture of the test. Okay, so, and I should have said chi-squared, not chi-squared. But there's a picture. So these things are always right-tailed. And so down here, this is 0, 0. And so this is 5 through 25, just because when we do the test here, the numbers are larger. So you got 13.277 as our test stats. So I just got the numbers at the bottom here larger because of that. Okay. The big thing here to see is it's right-tailed, always, for what we're doing. Okay. So we're going to do a right-tail test to see if we reject or fail to reject the null hypotheses. So obviously we need a test stat, right? We need that cutoff number. Okay, now where do we get that? Now that's where this table right here comes into play, table 6. Okay, now, so to get our test stat, we use table 6, and we're using degrees of freedom 5 minus 1. So 5 choices minus 1 is 4. Alpha they gave us as 0.01. Okay, so we go over here. There's the 0.01 column. There's the degrees of freedom 4, and we come across here, and there's our test stat. So are we to the right of that? Okay. Okay, so run the test on your calculator. Like I said, you got to go to list 1, list 2 on stat edit, and this is the observed. This is the expected. Okay, and then after that, I always quit. And then we need to go to stat test, right? And then you need to find, there it is, D, chi-squared goodness of fit test. Okay, so I go to that. There's the observed is list 1, expected list 2, and then I need to put in my degrees of freedom. Okay, then calculate. What do I get? 35. Yeah, that's a really big number. Okay, sorry. So 35, that's what I'm getting for my, my test stat. I was calling the critical value test stat earlier. So my critical value is 35. Well, obviously it's way, way up here. It's way to the right. Okay, so that means we are going to reject. Oops. Yeah, that's bad. H naught. Okay, now another thing you can check is, see, there's the probability. That's scientific notation. That means this number is 0.0000004. Okay, and that's obviously way less than 0.01. So that's another sign that we're rejecting the null hypotheses. So there's my critical value I got off the table. Sorry about calling that the wrong thing earlier. We get our test stat, 35, it's way up here. We're going to reject the null hypotheses. What does that lead us to? Okay, so we're rejecting this, which means, okay, now we're okay with this, that there is a difference. That's the claim. So you'll see in their interpretation, there is enough evidence at the 1% level of significance to conclude that the distribution differs.